My name is Jim Gibbons. I'm a construction supervisor with the Division of the State Architect, and I'm going to be presenting the electrical portion of the Project Inspector Overview training. The information that we'll be covering today comes directly from the California Code of Regulations, Title 24, Part 3, which is identified as the California Electrical Code, also abbreviated CEC, specifically the 2019 edition of the California Electrical Code. The following is a list of the electrical inspection overview topics that we'll be covering in this training today, and they are governing standards, applicable Form DSA 152 items, electrical safety, site and underground electrical, power distribution, location and clearances, wiring methods and materials, and conductors, branch circuits, and overcurrent protection. Additional topics that we'll be covering in the training today are equipment grounding and bonding, equipment anchorage and bracing, equipment supply and disconnecting means, luminaires, lighting control and receptacles, special equipment and special conditions, and electrical system tests. In this first section, we'll be discussing some general information relating to electrical inspection, as well as providing some introduction information. The California Electrical Code uses what we refer to as a model code for the basis for the actual California Electrical Code. The model code that we utilize is the 2017 version of the National Electrical Code, which is also abbreviated NEC. This particular code is maintained and held by the National Fire Protection Association, also abbreviated NFPA, and specifically the model code is NFPA 70. The 2019 edition of the California Electrical Code incorporates the NEC as the base regulatory document and also includes California and other agency-specific amendments, agencies such as DSA, obviously, OSHPD, the State Fire Marshal, etc. One of the most important forms that a project inspector uses on projects is the Form DSA 152, also known as the Project Inspection Card. This is a particularly important document used by project inspectors because they actually document evidence of inspection and completed inspections on this form. There are some sections on this form that may be utilized by project inspectors while they're inspecting electrical construction. Specifically in Section 1, which is titled Initial Site Work and Foundation Prep, there may be some blocks that the project inspector will be required to indicate their initials, identifying completion of inspections. Block 4, which is titled Utilities Rough-In, contains some subsections that may be appropriate. They are FLS Utilities/Systems, Electrical Utilities/Systems, and Electrical Vaults. In Block 6 of this same form is the area identified for concrete forming, and it is possible that there may be some fire life safety systems and some electrical systems, including transformer pads, etc., which may require project inspectors to initial upon completion of these tasks. Continuing with some additional possible entries which may be made by the inspector for electrical components or construction taking place is Section 3 of the Form DSA 152, titled Appurtenances. In Block 18, it is set aside for rated assemblies, and it's possible that electrical penetrations and also dampers that are installed would be appropriate. In Block 19, for fire alarms, fire and smoke alarm systems may need to be identified as completed by the project inspector. Block 21, titled Electrical Structural Support, Bracing, and Anchorage, may be appropriate for any type of electrical or pendant lights, transformers, switchgear, and IDF or MDF. Continuing with some items that may require project inspector initialing on the Form DSA 152, Section 3, Appurtenances. Block 22 is titled MEP Fire and Life Safety, and it's possible that MEP fire suppression systems, smoke and fire dampers may require initialing. Also, any kitchen hoods, laboratory hoods, dust collection systems, or smoke control systems and related construction may require some initialing. In Block 28, titled Other Work, Fire and Life Safety, it's possible that the inspector may need to make some notations for egress components, emergency lighting, and hazardous materials. Let's take a few minutes here to discuss just some general requirements relating to electrical systems. It's important to remember that electrical systems are generally diagrammatic. The plans basically provide a routing guideline to run conduits, conductors, and installing equipment and components. And it is certainly possible that the specific locations may differ somewhat from the plans. It's very important to remember that even though some differences may occur in the actual routing, that the electrical systems must not compromise the structural safety, fire life safety, or access compliance systems associated with the project. Along these same lines, any inadvertent conflicts which may arise between the electrical system installation and structural safety, fire life safety, or access compliance systems must be reviewed and approved by DSA. Additionally, these conflicts, since they are associated with the structural, fire life safety, and access compliance systems, there's a very good chance that a construction change document, or a CCD, may be required. And this is also going to be carefully reviewed by the district structural engineer. Article 90.1 in the California Electrical Code states the very purpose for the California Electrical Code, and that is the practical safeguarding of persons and property from hazards that arise from the use of electricity. So this is very important to understand, that the entire function and purpose for the California Electrical Code is for the protection of people and property. Since personal safety and property protection are the two main focuses of the California Electrical Code, it's important to talk a little bit about the basics of electrical shock. Generally, everyone is responsible for their own safety, and many hazards exist on a construction site. Based on data from the Occupational Electrical Injury and Fatalities that were categorized between 2003 and 2016, A number of workers died while being electrocuted on the job. Specifically, 2,648 workers have died of electrocution while on the job between 2003 and 2016. Additionally, 4 of those workers died from electrical burns. Another 4,210 workers received electrical shock injuries, and 5,160 received electrical burn injuries. All of these injuries were severe enough to require time off from work. The California Electrical Code re-emphasizes the need for personal safety and the importance of personal safety numerous times throughout the code by making the following statement. It is important that inspection authorities and users exercise more than ordinary care with regard to installation and maintenance. To briefly summarize, the majority of construction deaths on construction projects occur from falls, and the majority of electrical deaths occur from contact with energized overhead power lines. This slide includes a picture taken of a construction site sub-panel that really drives the point home that we're trying to express here. And as you can see, the danger sign basically says, danger. Not only will this kill you, it will hurt the whole time you're dying. And even though this is not a standard approved, maybe politically correct sign, it certainly drives home the point that personal safety must be emphasized at all times when inspecting any type of electrical system installation. Let's continue by discussing some data related to electrical shock. Specifically, electrical sensation of shock occurs at approximately 0.25 milliamps to 0.5 milliamps. And to quantify that, 1 milliamp is equal to 0.001 amps. Another way to look at that is 1,000 milliamps equals 1 amp. And remember that a standard household current varies between 15 and 20 amps. So a milliamp is an extremely small measurement of current. The uncomfortable sensation that a person gets is received when a current larger than 1 milliamp to 2 milliamps is received. The maximum let go level that a female can distinguish is 9 milliamps. For males, that same let go level is 15 milliamps. The fibrillation level, which is the level at which your heart will actually skip a beat or start to tremor after an electrical shock, is a function of the amount of current that is passing over a time. And the fibrillation level is defined as 500 milliamps over 0.2 seconds or 75 milliamps over 0.5 seconds. Continuing with the discussion of electrical safety, NFPA 70E, which is called the Standard for Electrical Safety in the Workplace, is an outstanding reference which identifies a variety of safety concerns and mitigation processes that would be helpful for any project inspector to review. The information is available. Most electrical contractors will utilize this resource during construction. And what we show here is a picture, or several pictures, which depict some standard lockout, tagout accessories and appurtenances which are used by electrical contractors, including warning signage. And obviously, all of these items follow a very stringent application process as well as a protocol for utilizing the locks that are associated, and also documentation of users utilizing lockout tagout procedures. This is a very important topic, and I would encourage all project inspectors to at least gain some knowledge about the standard use of lockout tagout. It'd be very helpful. The 2019 edition of the California Electrical Code includes some new and revised articles which we've listed here in red font and underlined, primarily for your informational purposes and for future reference as needed. Article 110.16b, arc flash hazard warning service equipment. Article 210.8b, receptacles GFCI protected for bathrooms, kitchens, rooftops. Table 250.3, additional grounding and bonding requirements, addresses network-powered broadband communication circuits that relate to Article 830.93 and 830.100, and also optical fiber cables, which relate to Article 770.100. Also, Article 250.284, grounding electrode use for separately derived systems, and Article 250.64b2, protection of 6 gauge or greater grounding electrode conductors exposed to damage. Continuing with some new and revised articles in the 2019 edition of the CEC, Article 250.68C2, hold-down bolts connected to structural steel columns are permitted for connection to concrete encased electrodes. Article 250.68C3, rebar may also be used to connect concrete encased electrodes to bonding jumpers in accessible locations. Article 300.5G, sealing spare or unused raceways for underground installations is required. And for Article 690, solar photovoltaic systems, there are numerous additions, and these are mainly design issues. However, it may be worth reviewing.